All right, now we're in section 8.5, and if you're thinking, oh, did I miss a section? Where's section 8.4? That's a section we're going to skip because it's, I don't know. It's a topic that pretty much only math majors and computer science majors, people that are going to learn how to program, they're the only ones that would ever need it. So we're just going to skip to something else that is actually useful for people outside those two majors, the binomial theorem. So this one, it answers the question, this is the idea behind the section anyway, it answers kind of something like, can we predict the terms of something like a binomial to a power, like, I don't know, let's say 3x minus 5 to the, I'm going to say to the 10th power, just to be crazy, without multiplying, or without foiling, I guess. Foiling repeatedly. Because if you think about it, what if I wanted to know what that statement there, that 3x minus 5 to the power of 10, if I wanted to know what that was equivalent to with no parentheses, I'd actually have to write 3x minus 5 10 times. That means 3x minus 5 times itself twice, times itself 3 times, on and on and on until you get to 10. And then you have to take turns foiling. So it'd have to be multiply these two out together, whatever you get, and multiply that by the next guy, and then on and on and on, all the way till the 10th one. That would take forever. And the chances are you're probably going to make a mistake somewhere in there. That's, not you, but anybody would make a mistake in there. That's a lot of multiplying and a lot of tedious stuff. So that's what we're wanting to do, is to be able to take this guy and just say, all right, is there a way to just predict what all the terms will be without having to actually multiply it out? And in this section, we find out that there is a way. It's kind of weird at first. It's kind of complicated, but we'll get the hang of it. So that's kind of what they mean by the title of the section, the binomial theorem. Binomial means two terms, right? It's a polynomial with two terms. We're going to want to know how to raise that to a power and be able to predict the behavior of it. Okay, but first things first, the binomial theorem contains this expression here. Let's see, where is it? I'm going to highlight it. This little guy. It looks weird, but we'll talk about it a little bit before we do any examples. So this, you would read this as n choose k. It sounds crazy, but it represents, represents the number of ways that k items can be chosen out of n items. And that might sound kind of crazy. What the hell are you talking about? But let's say, for example, what if I want to know I'm going to say in how many ways can I choose, I don't know, 5 of the 35 students in our class. So if I wanted to form a little small group of students that are going to work on some problems over here or something like that, and I wanted there to be 5 of them, I want to know how many possibilities are there. If there are 35 students in the class, how many possible ways are there for me to choose 5 of them? That's what this represents. And this, and you calculate it by using this formula. So it's n, which is the number you're choosing out of, factorial, which we've seen before, over k factorial, which, remember what that means? That means that number multiplied by all the smaller numbers, whole numbers, and then n minus k factorial. So lots of factorials. But that'll be involved in the binomial theorem, and we'll actually see it again in the coming sections, the probability section. Seen again in probability. I can't remember if that's the very next section or the one after. I think it might be the next one. I think so. But anyway, let's just practice it. So here in this first example that we have, specifically n is 6, because n is always the number at the top. So notice here's n, and then k is the one at the bottom. Okay, that means that 6 choose 2. That's like if you had 6 items and you want to know how many ways are there for me to choose 2 of those items. So the formula would say it's n factorial on the top, but 6 is n. Oops, and k is 2, sorry. I put a 6 for both, hello. And the denominator should have a k factorial, but our k is 2. And then n minus k, which is 6 minus 2 factorial. And then our job will just be to simplify this. I can kind of write that out. That's 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. In the denominator, we have 2 factorial, which is just 2 times 1. And then times, in parentheses, we have 6 minus 2, that's 4 factorial. Okay, and I might write that out real quick. Let me see here. The numerator is 6 times 5 times 4 times 3 times 2 times 1. The denominator has 2 times 1, but now that I have the 4 factorial, I'm going to write him out as well. That's 4 times 3 times 2 times 1. So just to reiterate, this 2 times 1 in the beginning, that was 2 factorial. And then the 4, 3, 2, 1, that was 4 factorial. And then at this point, it should be that everything from the denominator reduces with something in the numerator. So notice the 4's cancel, the 3's cancel, the 2's cancel, the 1's cancel. And then from there, let's see, we have the 2 in the front can go into the 6 3 times. So actually all that's left in the numerator is 3 times 5. And the denominator, all that's left is a 1. So it ends up being 15 over 1, which is 15. So that means there are 15 ways to choose 2 items out of a total of 6. Interesting. All right, let's try this other one. This one's interesting because we have the top number n is 8 and the bottom number k is 2, 0. So if you think about this, I almost feel like we can guess the answer, but we're going to use the formula anyway. This is asking how many ways are there for me to choose 0 items out of 8. So if you had 8 items in front of you and you wanted to choose none of them, how many ways are there for you to do that? I would think there's only one way to choose none. I just don't choose any. You know, that's what I'm thinking. I'm thinking the answer is going to be a 1, because how many ways are there to choose 0 out of 8? Anyway, but the formula is supposed to be, I want n choose k. It's supposed to be n factorial over k factorial, and then n minus k factorial. So I'll fill everything in that we know. N is 8, so it'll be 8 factorial over k factorial, that's 0. And then n minus k, that's 8 minus 0 factorial. And then just something to point out that you might see again. It kind of actually doesn't make sense to talk about 0 factorial. You know, because remember we said factorial means take that guy and multiply it by all the smaller whole numbers, but 0 isn't even a whole number, so it doesn't even make sense. But we just say that this is equal to 1 by convention, or by, we define it that way. I'm going to say by definition. So if you ever happen to come across 0 factorial, just know it's 1. So I'm going to replace this 0 factorial with a 1. Kind of like with imaginary numbers, I squared is 1. I guess it's like that. So the numerator I'm going to write out 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. The denominator had a 0 factorial, but we already said that was a 1. And then I'm going to simplify this guy. The 8 minus 0 is 8 factorial. So I'm going to write out the numerator one more time. 8, 7, 6, 5, 4, 3, 2, 1. The denominator has a 1 times, but then 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But if you notice, everything's going to cancel here. It's going to be the 8's cancel, the 7's cancel, the 6, the 5, the 4, the 3, the 2, the 1. So if you cancel everything from either the numerator or the denominator, automatically there's a 1 left. The denominator also has a 1 left, so the answer is 1. There's only one way to choose 0 items out of 8. And the 8 wasn't special. The 8 could have been anything. Could have been anything choose 0 is going to be a 1. So like 35 choose 0 is 1. 100 choose 0 is 1. But okay, let's try this next one. We got 100 choose 2. That means n is 100 and k is 2. So we want n choose k is n factorial over k factorial times n minus k factorial. Let's see here. So n is 100. Let's see, that's 100 factorial over k factorial, that's 2 factorial, over n, which is 100, minus k, which is 2 factorial. Let me see. And this is where I'm kind of hesitating. I don't really want to write the numerator out. 100 factorial, that's a lot. So I might think about this for a second. I'm just going to leave it as 100 factorial for now. The denominator, let's see, I have a 2 factorial. I'm going to write that out. That's not so bad. 2 factorial is 2 times 1. And then I have 100 minus 2, that's 98 factorial. All right, let me see here. And you know what? What I'm thinking is, I think this will help us simplify these guys in the future too when we do this example now. That 100 factorial, okay, if you think about it, that's, it's 100 times 99 times 98 times 97, and times 96, on and on and on until you all the way to 1 and 2. But if you wanted to, because I see a 98 factorial in the denominator, what if I write this as 100 times 99 times, and then what's left, notice is, okay, that's 98 times 97 times 96, on and on and on. What's left is 98 factorial. So I think that's kind of what you want to do when you see big numbers like this, especially 100 factorial. I really don't want to write that out. And then 98 factorial, I don't really want to write that out. But what I can do is say, well, 100 factorial is, let me pull the 100 off and pull the 99 off. But then what would be left is 98 times 97, times 96, which I can write as 98 factorial. And I do that because I know that that's going to cancel with the 98 factorial in the denominator. So it's kind of nice. Yeah, if you see large factorials like these guys, you got 198, this guy and this guy. It's not a bad idea to write it. Instead of writing it out, just take the one that's larger and pull out a couple terms until the remainder matches the smaller number. And then we should have those 98 factorials canceling. Let's see here. Cancel, cancel. And then what's left too, some things cancel. The 2 can go into the 150 times. So the numerator, it ends up being 50 times 99, which is 4,950. And the numerator only, the denominator only has a 1 left, so it'd be that over 1, which is just that, 4,950. That's a lot. So remember this, this n choose k that we were given in this example, 100 choose 2, that's saying how many ways are there for me to choose 2 items out of 100? That's a lot of ways. But if you think about it, the further apart those numbers are, the 100 and the 2, the larger the answer is, because if there's 100 to choose from and I want to choose only 2, there's a lot of possibilities. So it kind of makes sense that the number would be large. Okay, let's try this last one, and then I think we're ready for the kind of the meat of this section here. This time n is 14 and k is 1. And this one, I think, like the one we did 2 problems ago, I think we can kind of predict the answer, because if you think, what does this mean? This is representing the number of ways I can choose one item out of 14. So that's like, imagine you have 14 items in front of you, and I just want to choose one of them. Well, how many ways are there to do that? Well, there's 14, because you can either choose the first one, or the second one, or the third one, or on and on and on to 14. So I'm kind of expecting the answer to be 14, but we'll see. Let's fill everything in. N factorial over k factorial, n minus k factorial. Okay, and then n factorial, that's 14 factorial over k is 1, so 1 factorial. N is 14 minus k, which is 1 factorial. All right, looks good. So I'm not going to write out the numerator yet. I'm just going to leave it as 14 factorial. And then 1 factorial is actually just 1 because the factorial says I want to multiply this number by all the smaller whole numbers, but 1 has no smaller whole numbers. So it's just 1, and that's it. And then 14 minus 1 factorial, that'd be 13 factorial. And at this point, I think I'm going to do like we did in the previous one, where 13 and 14 factorial, there's kind of a lot of terms if I write that out, 14, 13, 12, 11. I think what I'll do is I'm just going to extract the 14 off, and then what would be left if I take the 14 off, the 14 factorial is 13, 12, 11, 10, 9, all the way to 1, which I could just write that as 13 factorial. And then the denominator has 1 times 13 factorial. And writing it like that allows me to cancel the 13 factorials, just leaving the 14 over 1, which is 14. And that's what we kind of predicted. There are 14 ways to choose one item out of 14. Okay, now let's get to the meat of this section, the binomial theorem. But you know what would help maybe? Oh, we have one more. I'm sorry. I didn't see this guy. I'm getting a little ahead of myself here. Let's see. Here in this case, n is 21 and so is k. So I'm going to fill those in. And I think this one we can predict if we think about it. Because this is asking, how many ways are there for me to choose 21 items out of 21 items? Well, if I'm taking all the items, because I'm taking 21 out of 21, there's only one way to do that. Just grab all of them. So I think the answer is going to be 1, but we'll see. 21 factorial, because that's n, and then k is 21. And then n minus k, that's 21 minus 21. Oops. So we got a 21 factorial in the denominator. We have another one in the numerator. And then 21 minus 21 is going to be 0 factorial, which we already said was 1. Remember we said 0 factorial equals 1. We just define it that way because it kind of makes things easier. So we got 21 factorial over 21 factorial times 1, which would just be a 1 because there everything would cancel. The 21 factorials cancel to leave a 1 over 1, which would be 1. So kind of like we predicted, there'll only be, one way to choose 21 out of 21 items. Okay, so you know what? I think from a few of those, we can make some rules here. Rules, okay. There was one where we said the number in the numerator, the top number didn't matter, but if the bottom number was 0, let's see, where'd that one come from? That was part A. So 8, that 8 didn't matter, it's just, because that's asking, how many ways can I choose 0 items out of 8? Well, there's only one way to do that, because you just don't choose any, right? But that 8 wasn't special, that 8 could have been anything, so we're going to make a rule now. If you have n choose 0, n can be whatever the hell you want, the answer is always going to be a 1. So we got that guy. And I think if you make the k value 1, then the answer is going to be n. That was kind of like, what was that like? We did one like that in, did we see that guy? Yeah, in part 1D. So this one was like 1A. We saw this in 1A. We saw an example like this in 1D. And then we just saw in 1E that it seems like if I have the same number on the top and the bottom, like n choose n, then I'm going to get a 1 as well. So I think these, if you kind of keep these rules in mind, that might help you with the coming thing, the binomial theorem. So I'm going to keep those in mind. Whenever I have a 0 as the k, my answer is going to be 1 when I do n choose k. When k is 1, my answer is always going to be n. And when k is equal to n, both numbers are the same, I'm going to get a 1 as well. Okay, so the binomial theorem, this is what we've been promising this whole section. So this is answering the question, like we said, can I predict what happens when I take a binomial and raise it to a power without having to actually multiply the whole thing out? So the answer, you can write it as a sum, but I think the more useful one is looking at it like this. So this is what it'll look like. It looks very complicated, but I think you can notice a pattern. So notice that there are a few n choose k things going on here. It starts out with n choose 0, and then n choose 1, and then n choose 2, and I guess the next one would be n choose 3, n choose 4, n choose 5, all the way until you get to n choose n, where n is the exponent, you know, that the binomial is being raised to, a plus b to the n power. So I think I can kind of predict that's the coefficients. Those n choose k's, those are going to be the coefficients of your terms. And then it looks like what's happening to the a terms, which will be the first, I guess that's like the first term of your binomial. You're raising a to the n power, so that's just the exponent that was on the binomial that you're trying to figure out. And then the next term has 1 less power than that. And then the next term has 1 less power than that. You're decreasing the powers on a by 1. So that's another thing I'm noticing. We're decreasing the powers on a by 1, but we begin at n. So the very first term in this expanded binomial theorem is going to have a to the n, where n is the exponent we're interested in. And then from there it's 1 less than that, 1 less than that, and then keep going and going and going until you get to a to the 0. The very last term should be a to the 0. And then for the b terms, which are the second terms in your binomial theorem, let's see here. This guy, whatever the second term in your binomial was, you're going to start out with that guy to the 0 power. So he's actually starting at the smallest power, and then he's increasing by 1 every time. So 0 power, 1 power, 2 power, and then on all the way to the nth power, where n is the power you're trying to raise the binomial to. So that's a lot to take in, but the more examples we do, the better it'll get. We'll kind of break it down pretty well, I think. So b's, though, you're increasing the power on b by 1. You know, as you go from left to right, you got 0 power, 1 power, 2 power, beginning at 0, b to the 0, and ending at b to the n. So that's kind of what's going on, just to make an observation of this binomial theorem. Okay, that might make this problem easier. So this first one they're asking about is x plus 1 to the 4th. So let me identify all the parts. A is the first term of the binomial, so x. B is the second term of the binomial, so 1. And then n is the power we're trying to raise it to. Okay. So let me see. It should start out with n choose 4, or sorry. I'm trying to just trying to fill this in. So it looks like, maybe if I write it down, it's n choose 0, a to the n, b choose 0, or b to the 0 plus n choose 1, a to the n minus 1, b to the 1, and then on and on and on and on until I get to n choose n, a to the 0, b to the n. That's basically how this binomial theorem looks. Let me start filling in what I know, the a, the b, and the n. So let's see here. Maybe I'll color code it to make more sense. I'm going to fill in all the a's with x. So here's an x, here's an x, and then all the way at the end was an x. Let's see. What else? We got the b was a 1. Let me fill that guy in. There's a 1 here, a 1 here, and a 1 here. Maybe I'll put a little, multiplication sign between them so I know what's going on. But their exponents are staying the same. But I'm going to fill in n now. N, let me see, I'm going to choose a different color. Here we go. N is 4. Let me fill in 4 for n. So that means that this n choose 0 is actually 4 choose 0 because n equals 4. And then an a to the n power, n is 4. B to the 0 power, but 0, doesn't change. And then the next one, you have n choose 1, but our n is 4. And then a, which is x, to the n minus 1, but again, n is 4. So 4 minus 1. And then b to the 1 power. All right, and then I'm not sure really how many terms are in here. It kind of depends what n is. I think we'll figure it out. But this very last guy, n choose n, that means 4 choose 4. And then a to the 0 power, so x to the 0 power, and then b to the n, but n was 4. All right, now I think about what kind of, how many terms are missing in between where this dot, dot, dot is. So let me see, I should see every successive power. So notice, for example, I have 1 to the 0 power, 1 to the 1 power, and then at the very end I have 1 to the 4th power. So I feel like I'm missing the 1 to the 2nd power, and 1 to the 3rd power in here somewhere. So I think that there are 2 terms that are in that dot, dot, dot area. The terms. I think the next step is I'm going to figure out what's going on in that dot, dot, dot. Let's see. The first term here, that's 4 choose 0, x to the 4th. And then I know that 1 to the 0 power is 1, but I'm just going to write it as is just for now so I don't confuse myself. And then it's 4 choose 1, x to the, I guess I can simplify this. 4 minus 1 is 3. Times 1 to the 1 plus, and then we said we're missing the next term, so it's something, something, something times 1 to the 2nd power. I'll think about that. Plus, and we said we're also missing the 1 to the 3rd term, so I must have some kind of something n choose k going on there. X to some power times 1 to the 3rd plus, all right, now we're finally on that last term there. 4 choose 4, x to the 0 power times 1 to the 4th. Now I just got to fill out kind of what's missing. For now, I think I'll put a question mark. I'm thinking, I don't know what this is. I don't know what this guy's power is, but I think we can figure it out by kind of looking at the pattern. So notice the choose things, the 4 choose 0, 4 choose 1. And then I would think the next one's 4 choose 2, just because that's the pattern. And then 4 choose 3, and then 4 choose 4. And that's exactly how it goes. The top number in your n choose k is always n, so 4 every time. But the bottom number goes from 0 to n. It goes from 0, then 1, then 2, then 3, then 4. So we got that filled in. And then I notice that the powers on x are decreasing like we described. 4, 3, and I'd imagine this is going to be a 2. This guy's going to have a 1 and then a 0. So that makes sense. There's kind of every successive power from 4 to 0 is in there. All right, and that's pretty much it. Now it's just a matter of simplifying this, kind of see what you get. So this first n choose k, the 4 choose 0, I can use my rule that I came up with up here. Remember, n choose 0 up here, the very first one that we wrote, is equal to 1. I know this guy's a 1 based on our rule, times x to the 4th, and then 1 to the 0 power is just 1. So I know that's going to be cleaned up really nicely. And then 4 choose 1, that kind of goes to our second rule. Where's that? 4 choose 1, we said anything choose 1, that's our second rule, is going to be n. So in particular, 4 choose 1 is going to be 4. And then we have x to the 3rd times 1 to the 1 power. Plus, okay, now I have to think about this. 4 choose 2. That one you might have to go off and do on the side. Let's see, 4 choose 2. That's going to be 4 factorial over 2 factorial times 4 minus 2 factorial. So let me see, I'm going to write that out. 4 factorial is 4 times 3 times 2 times 1. The denominator is 2 factorial, which is 2 times 1. And then 4 minus 2, that's 2. So you got another 2 factorial sitting down there. So I'll write 2 times 1. And I think most things should cancel here. Let's see, I can say this 2 goes into this 4 twice. And these 2's just cancel all together. So you're just left with 2 times 3 in the numerator and a 1 in the denominator. That's 6. So it looks like this guy's going to be a 6, this 4 choose 2. And then next to it was an x squared, so I'll write that. Times 1 squared is just 1 plus 4 choose 3. Now I got to think about that off to the side. 4 choose 3, that's going to be 4 factorial over 3 factorial times 4 minus 3 factorial. So I'm going to rewrite the numerator out. That's 4 times, let's see, 3 times 2 times 1 over 3 factorial is 3 times 2 times 1. And then this guy, 4 minus 3 factorial, that's really 1 factorial. But we said before that 1 factorial is just 1, because 1 factorial means multiply 1 by all the smaller whole numbers, but there are no smaller whole numbers. And then I should get a lot of canceling going on here. This 3 and this 2 cancel. So you're left with 4 in the numerator and 1 in the denominator, which makes a 4. So it looks like this next n choose k is a 4. And next to it was an x to the 1 power, so we got that. And then times 1 to the 3rd power is just a 1 plus. Now 4 choose 4, that goes to our third rule there. Where is it? The third rule where it's n choose n, where if n and k are the same, you're just going to get a 1. So that means that this 4 choose 4 is just 1 times, and then x to the 0 is 1. Anything to the 0 is 1, times 1 to the 4th, which is 1. All right, I think we have it. I'm just going to clean this up a little bit. Let's see here. This guy simplifies to just x to the 4th. This is 4x to the 3rd. This guy's 6x squared. The next one will be 4x. And then the last term is just a bunch of 1's added together, so it'd be 1. And that's it. So that would be what you would get if you took x plus 1, wrote it out 4 times, and then multiplied it all out. This is what you should get. Whew, it's pretty complicated. Oh, Lord. Okay. Let's try this next one. This is pretty serious. In this one we have a is supposed to be the first term, so x. And then b, you got to be a little bit careful because remember the model of this, where was it, the beginning guy? It has a plus b to the n. So we're assuming there's a plus in the middle. But in this one I have a minus, so what you have to do is think of it as x plus negative 2y. So if there happens to be a subtraction sign between your two terms, you have to kind of assign that subtraction sign as a negative to b. So b won't just be 2y, it'll be negative 2y. But then otherwise we can treat it as we did the previous problem. And then n is the power I want it to raise it to, 5. Alright, I think we're ready. It's supposed to go, what is it? N choose 0. So we'll start with that. N choose 0. And then a to the n, b to the 0 plus n choose 1, a to the n minus 1, b to the 1, and on and on all the way to n choose n, a to the 0, b to the n. That's how it should look. Let me just fill in n equals 5. We have 5 choose 0, and then a to the n. That's going to be something to the 5th power because, again, n is 5. But then a, let me see here, a is x. So wherever the a's were, I'm going to put an x. And then wherever the b's were, let's see, where's b? he's negative 2y, so he's going to go here. And I would put it in parentheses just to be safe. And it already had a 0 power, so just keep it. And then the next term should have a 5 choose 1. Let me see here. 5 choose 1, because n is 5. And then it'll be a, which is x. Let me see here. To the power of 5 minus 1, because n is 5. And then b to the 1 power. Let's see, b was negative 2y, so I'll write that guy in there. Negative 2y. Okay, so far so good. And then let me think about how many terms would be missing. Let's see. Because this guy, if I were to write this out, this is going to be, since n is 5, it's 5 choose 5, a to the 0, b to the 5th. I'm thinking, okay, I have my first term 5 choose 0, and then it's 5 choose 1. I want to go all the way to 5 choose 5, so I think I'm missing 3 terms. I need a 5 choose 2, and then something with the x with the power, negative 2y with the power, because those are a and b. And then in 5 choose 3, let's see, 5 choose 3, x to some power, negative 2y to some power. And then a 5 choose 4, and I'm almost there. X to some power, negative 2y to some power. And then lastly is the one the very last term that we found. 5 choose 5, x to the 0, negative 2y to the 5th. So that's kind of how you know how many terms are missing, is just think, the very last term I would need n choose n, or 5 choose 5. And the one that I had written before the ... was this guy. So from 5 choose 2 to 5 choose 5, how many things are missing? Well, in other words, how do you get from 2 to 5? You need a 3 and a 4 in between, I guess, is the idea. Oh, Lord. But then I need to figure out the powers here. But let's see. You know what, though? What you can do is just think the powers on x are going to decrease by 1 every time. Oh, I should say the powers on x are decreasing, so you can kind of come up with the exponents on x. So for example, I started with the 5, this is going to be a 4, so then it should go 3, and then 2, and then 1. And then the powers on, what's it called, negative 2y are supposed to increase. Powers on negative 2y, because that's your b value, are increasing. So since it started with a 0 power, and then it went to a 1 power, the next power must be a 2 power, and then a 3, and then a 4, and then a 5. Okay, yeah, that makes sense. Man, that looks good. Okay. And then to simplify these n choose k's, I think I can use some of them I can use rules. So let's see, 5 choose 0. Let me see here. Where'd he go? 5 choose 0. We said anything choose 0 is 1. So that's a 1 times x to the 5th times, and then negative 2y to the 0 is just 1, because we said anything to the 0 power is 1. Plus, okay, 5 choose 1, we said anything choose 1. That was our second rule. N choose 1 is that number n, 5 in this case. Then we have x to the 5 minus 1 power is 4, and then negative 2y to the power of 1, which would just be negative 2y. Okay, and then 5 choose 2, that you'd have to go off to the side and calculate. Or use your calculator, I guess. But if you did, you would... Let's see, you should get 10. Excuse me, and then x to the 3rd, negative 2y to the 2nd. Okay, and then I think the next guy, the next choose, you'll have to actually use your calculator as well, or use something. You have to go off to the side and calculate that. 5 choose 3 is also 10. And then you have x to the 2nd power, negative 2y to the 3rd power, plus, okay, 5 choose 4, that's another one you might have to calculate off to the side. And then you know what, after we're done with this problem, because I don't want to confuse everything right now, once we're done with this problem, I'm going to show you how to use your calculator to calculate these guys. If you happen to have a Texas Instruments calculator, that is. It's okay. Anyway, 5 choose 4, that would be 5. And then x to the 1 power, which is x, negative 2y to the 4th power. Okay, then 5 choose 5, that's our third rule. We said n choose n is going to be 1. X to the 0 power is 1. And then times negative 2y to the 5th. Okay, I think we have this almost as simplified as it can be. Let's see here. The first term is just x to the 5th. And then we have, I might be careful here, I have 5x to the 4th. Oh wait, that I don't have to really be careful with, I'm sorry. I was thinking that the negative 2y had a big power on it, but it doesn't. So I think I'm able to just multiply those right now. That would actually be a minus sign because it's a positive 5 times a negative 2, so it would be 10 x to the 4th y. And then let's see, you can kind of just write this off, you know, right below this. Negative 2y to the 2nd power is 4y squared. So I'm multiplying 10x to the 3rd times 4y squared. That'll give me 40x to the 3rd y squared. And then, okay, plus or minus, I don't know, we'll see. Negative 2y to the 3rd power is negative 8y to the 3rd, because you're having to cube the negative 2 as well as the y. And if I multiply that by the 10 in the front, 10x squared, it's actually going to get a subtraction sign, 80x squared y cubed. And then we have, let's see, negative 2y to the 4th power is going to be 16y to the 4th power, which if you multiply that by 5, you get another 80, and then x times y, to the 4th power. And then here, negative 2y to the 5th, that's negative 32y to the 5th, which if you multiply that by 1, you still just are stuck with negative 32y to the 5th. Whew, so I think this is what the answer would look like. It's easy to make a mistake. But you know, if the binomial has a minus sign in between, like ours started, you should see alternating signs. Notice the first term is positive, the second term is negative, the third term is positive, fourth term is negative. It should go, yeah, positive, negative, all the way to the very last guy. That's a good sign. And then the powers on x should be decreasing by 1. The powers on y should be increasing by 1. Oh, that's a good sign. So anyway, on your calculator, this is if you have a TI 30 or anything in the 30s, like a 30x or a 32 or anything in the 30s, where you're calculating is n choose k, but there's another way to write it. You can use, we'll see this in a section that's coming. They call it a combination. It's the exact same thing, but you'll find that if you press the probability button. So if you have that calculator, look at it and try to find PRB. If you see that button, you'll see an option for NCK. So what you'll want to do is, for example, let's say we're trying to calculate 5 choose 2 or something like that. Well, another way to write that would be 5 choose 2 like that. And what you do on your calculator is, let's see, on calculator, you'd press the 5 button, and then you'd go to PRB because you want to now grab the N choose K thing. And when you press PRB, you'll see N choose K. You want to scroll over to it and press enter so that you have it. So your screen now should show 5 N choose K, but now it wants to know what K is. Now you press the 2 button. So your screen should show this, and then you'll press enter. And I think you get a 10 in this case if you want to test it out. But that's how I was doing those so quickly up there, those choose things. So I don't want to tell you that at first, I guess, because we want to know how to do it by hand and all that. But maybe that'll help us with this example. We have the very last one here, and then we're moving on to the very last objective. So we want to be able to expand this guy. Let's see. So in this case, I'm going to see what A, B, and N are. A is the first term, x squared. B is the second term, 2y. And N is 4, because that's the exponent we want to raise things to. So it should look something like, okay, N choose 0, A to the N, B to the 0, plus, okay, and then you're increasing the K value in the N choose K by 1. So it should be a 1 now, and then a 2, and then a 3. The power on A should be decreasing by 1. The power on B should be increasing by 1. And then on and on and on until you get to the last term where the N choose K, the N and the K are the same. They're both N. A is now raised to the 0 power, and B is raised to the highest power, N. So let me kind of fill in, and then I think we'll kind of see what terms are missing in that dot, dot, dot. N is 4, so it looks like 4 choose 0. A is x squared. I'll think about the power on A, and then B is 2y. So you know what? Yeah, I'm going to fill in the exponents later. Right now I'm just going to fill in N and A and B. So N choose 1, that's 4 choose 1. A is x squared to the power of N minus 1. We'll find out, figure that out later. And then B is 2y plus, okay, let me think about what's missing in there. There's something missing, I'm going to leave some space. Blah, 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 blah. This guy, though, N choose N, that would be 4 choose 4, because we said N is 4. And then A to the 0, but A is x squared. And then B, which is 2y to the N, okay. I'm just kind of thinking what's missing here. We have, basing it off the N choose K, 4 choose 0, 4 choose 1. The next thing would be a 4 choose 2, all the way to 4 choose 4, but I think what I'm missing is a 4 choose 3 also. Alright, so it looks like in the dot 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 area there were 2 terms missing. I have that 4 choose 2 times a, which is x squared to some power, times b to some power, plus, okay, and then the next term 4 choose 3 times a, which is x squared to some power, b, which is 2y to some power. Okay, now I'll fill in the powers. On the very leftmost term, a should have an n power, but n in this problem is 4, and then b should have a 0 power. And then from there, you're just decreasing the power on a by 1. So it was a 4, now it's a 3, and then it'll be a 2, and then it'll be a 1, and then it'll be a 0. And then on b, which in this case is 2y, we start out with a 0 power, and every time we're increasing by 1. So then it'll be a 1 power, and then it'll be a second power, and then it'll be a third power, and then finally a fourth power. Alright, now I'm ready to just simplify this. So 4 choose 0, you can either use a calculator or use our rule. That's going to be a 1, and then x squared to the 4th, remember you multiply the powers. So it'll be 2 times 4 is x to the 8th, and 2y to the 0, anything to the 0 power is 1 no matter what. Plus, okay, then 4 choose 1 is 4, either using the calculator or one of the rules that we came up with. X squared to the 3rd, if I multiply those powers, I get x to the 6th. Times, and then 2y to the 1 is just 2y. Plus, okay, here you can use a calculator if you want, and the way we showed is 6. This guy. And then x squared squared, that's going to be x to the 4th, if you multiply the powers. And here you got to be really careful, so let me highlight what we're doing here. We're looking at 2y to the 2nd power. I have to square not only the y, but also the 2. So I'm squaring 2, which will give me 4, and I'm squaring the y as well. So be careful on that. When you have two things multiplied together, and they're being raised to a power, then each of them should get that power. Let's see, and then 4 choose 3, let me use my calculator here. That's going to be 4 times, and then x squared to the 1 power is x squared. 2y to the 3rd, kind of like we described before, I have to cube the 2, I'm going to get 8. And then I'm cubing y as well. Okay, and then the very last guy, 4 choose 4, that's from one of our rules, that's just going to be a 1. Or if you use a calculator, you should get a 1. And then you have x squared to the 0 power, but anything to the 0 power is 1. And then times, I have to raise 2 to the 4th, that's 16, and also y to the 4th. Okay, I think we have it if we simplify this. That's x to the 8th. Our first term is x to the 8th. Then we have 4 times x to the 6th times 2y. That'll make 8x to the 6th y. Plus, okay, then these guys, 6 times 4 is 24. Then we have x to the 4th y squared. The next term, 4 times 8 is 32, x squared y cubed. Then you have 1 times 16, which is 16y to the 4th. Wait, am I missing something? No, I think that's, okay, that looks good. Alright, yeah. That's a lot of work. But don't worry, there aren't too many problems like this, thank God. Or else it'd be very tedious. Alright, then the very last objective we have here in this section, thank God, this is getting real old, is, like let's say, okay, you had a binomial raised to a power, kind of like one of the ones we were given. Let's just say that previous one, like this guy. But what if for some reason you didn't really care about the expansion, every single term of the expansion? Let's say you just cared about, I don't know, the 3rd term, let's say I said, you know, I know there's a bunch of terms of this expansion, but all I really want is that 3rd term. Is there a way, like a faster way to figure out just the one term you want without having to find all of them? So this should give us a formula for that. So let's see. Okay. Where are we? Okay. It says a plus b to the n has general term da 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 da. So to find any specific term, set r. So for example, if you want the 3rd term, you let r equal 3. Da 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 da. There we go. Or sorry, which is the 4th term of the expansion. Oh, okay. Ew. Actually, I'm sorry. I don't know why the way they phrased it was kind of weird. So I might not go by what they said over there. I'm sorry. I thought that was a nice simple formula, but it's not. This is better. So if you want the rth term, let's say they want the 5th term. Okay, then you just replace r with 5, and then n is whatever power. And this is what you would need. And it's very complicated, but you know, what are you going to do? So for this, let's see, this first example, I'm just going to write out that formula so I have it in front of me. So the fifth term is I need n choose r minus 1, a to the power of n minus r plus 1, b to the power of r minus 1. That's what we're looking for. So in this particular example, I just have to identify what are all those parts. What's the a, what's the b, what's n, what's r. So in this case, a is the first term, 2x, b is the second term, y, n is the power, on the binomial 9, and then r, the very last guy that we have, this is the first time we've seen r. It's just the term you want. So this time the fifth term, so r is 5. Okay, and then I'm just going to fill those into this little formula here, and that should be it. So let's see, n was 9, right? Okay, so 9, choose, r is 5 minus 1, a to the power of n, which is 9, minus r, which is 5, plus 1, b to the power of r, which is 5, plus 1. All right, and then I'm just simplifying this until I get a nice value. This would be n choose 4 because 5 minus 1 is 4. So we'll think about that. But let me see. Now that I've kind of got n and r in place, I'm going to replace a and b. A is 2x. So let me see. What did that guy look like? 2x will go there. Okay, 2x. But then it's to the power of, what the hell is this? 9 minus 5 is 4 plus 1 would be 5. Okay, and then b, what was he again? We said b was y, right? Is that true? Yeah. B was y, so I'll replace this guy with y. And then his exponent, of course, simplifies to 6. All right. And this you can just use your calculator for. Let me see here. 9 choose 4 is going to be 126. And then 2x to the fifth. I have to raise 2 to the fifth power. That's 32. And then x to the fifth power. And then this, of course, would just be y to the sixth. So now my job is pretty much just multiply the 126 by the 32 to give me 4,032. And then there's the x to the fifth, y to the sixth. That would be the term. The fifth term, if you were to expand that binomial raised to the ninth power that we were given. Thank God I don't have to do that. Ugh. All right, I think we'll do that one more time, and then I think we'll kind of get the hang of it. It's just, man, you really need to write these formulas down. I don't know how people would memorize them. That's crazy talk. Here, the first term a is x squared. The second term b is y to the third. N is the power that this binomial is being raised to, which is 8. And then r should be the term we want. In this case, the sixth term. Okay, r must be 6. Let's see. All right, if I fill those into the formula, then I should be, as long as I'm careful, I should be okay. So I already forgot what it was. N choose, was it r minus 1? I already forgot. Yeah, r minus 1. And then a to the power of n minus r plus 1, b to the power of, I already forgot, r minus 1. There we go. All right, let me fill everything in there. Okay, blah, blah, blah. But remember, c, that's just part of the notation of n choose r. So that doesn't need to be replaced. N needs to be replaced, so that's 8. Choose, and then r was what? 6 minus 1. Okay, good times. A is, what was he? X squared. And then to the power of, let's see, n is 8 minus r, which is 6. And then plus 1. All right. And then b, what the hell is b? B is y to the third. And his power, I didn't leave myself a lot of room. Let me see here. Watch out, buddy. Get your butt out of the way, am I right? Sheesh. There we go, okay, and then the power is r minus 1, but r is 6 minus 1. Okay, let me simplify that. That's 8 choose, 6 minus 1 would be 5, okay. And then you got x squared to the power of, what the hell is that? 8 minus 6 is 2, plus 1 is 3, okay. And then you have y to the third to the power of 6 minus 1 is 5. All right, now we got this. I'm going to use a calculator here. Use a calculator, or if you don't happen to have one handy, you can go off to the side and calculate that, like we did in the very beginning of this section. 8 choose 5, that's 8 factorial over 5 factorial times 8 minus 5 factorial, and that'll work. It's just tedious. I just feel like now that we know how that works, I'm just going to use a calculator. Once I feel like I understand something, and I can do it by hand, I probably don't have to. I know what's going on, so I don't really need to prove myself. Okay, and then x to the power of, if I multiply those powers, I get 6. Same thing with y's, I'm going to get 15. Whew, there he is. Hello. That's a lot of work, huh? But that's probably one of my least favorite sections. But it gets more fun. The next section's a lot more interesting, I think. Not many sections left to cover, so try not to cry and be too sad.